We are on day 3 working through quadratics. And again, I'm going to go through 3 problems here, and then you're going to do the other 3 for homework. And I want to start with number 13. So up until this point, the clues I've given you, I've either given you standard form to start from, or I've given you vertex form to start from. And now this problem, I don't give you either of those. Instead, I've given you a couple clues from the graph. We still need to find all those pieces, but we're starting with something different now. In the graph, the V, if you see a V there, that's representing vertex. Okay. So we have a vertex at -3, -6, and we might as well fill that in. That's given to us. And then we're given another point, -7, 18. Okay. So -7, 18. Well, let's start here. The axis of symmetry. Let me start asking you guys some questions. So Joyce, what's the axis of symmetry going to be? You know? Not sure? So the axis of symmetry goes right down the middle. Okay? The vertical line cuts it right down the middle there. And whenever you have a vertical line, it's always x equals something. You know what number I should pick, Joyce? -3. Good job. Okay. It's the same x value that the vertex has, because the vertex is in the middle as well. Okay. So we have our vertex, we have our axis of symmetry. Also in our picture, whatever points you know on the left side, you also know on the right side, and vice versa, because there's a symmetry. And so we have this point -7, 18 on the left side, and there's going to be this reflected point on the other side of that. And Elijah, what's that point going to be? It will be the same height as both those points will be the same height, meaning they both will have the same y value. So what will that be, Elijah? Good. So they're both going to have a height of 18 because they're at the same height. And they're both going to be the same distance from the center. So how far are both those points from the center from -3? 4. So, and that's how Elijah came up with the 1. He said, okay, the center's -3. There's a distance of 4 from -7 to the center. So I'm going to add 4 more to -3. -3 plus 4 gave him the 1. Okay. Good. Domain, all real numbers. The range, Leah, what's the range going to be? Good job. Okay. The lowest point of this graph is -6, and so it's all y values above that, and also you got to include it, so greater than or equal. Where is this increasing? Let's go with Sue. Good job. And where's it decreasing, Sue? Very good. Okay, so those are kind of the obvious things that we can get quickly from what's given. A lot of stuff about the graph because the graph was given to us. What we're not getting is all the equation stuff, right? And we need to come and we need to get these equation things eventually. Which equation do you think we're going to be able to find first? Standard form. Do you have an idea how to do that? Vertex, because we know the vertex, and so we know a lot about the vertex, but I don't know the x-intercept. I don't know y-intercept. The other ones, I don't know, right? So we know something about the vertex form. And vertex form, you need three things, A, H, and K. How many of those three things do we have? We have two. We have H and we have K. So if we could find A, then everything's good. Okay, we can definitely assume A is going to be positive because the graph is opening up. Yes. But positive what? We don't know. So here's how you start this. You're going to write y equals A because we don't know what A is, and you have to put A there. If you don't put an A there, then you're saying you know what it is. X, what comes after that? Plus 3 squared, and then minus 6. And now let me show you, I included a little notes down here for this very thing that we're doing. Okay, so if you know the vertex of a parabola, we do, and another point that it passes through, we do, then you can find the vertex form of the equation. And you need those two pieces, the vertex and an extra point. That extra point is going to help us find A. So here's what we do. We plug the vertex into H and K and into that equation we just did that. Then we're part B, this is where we're at. We're going to plug the other point in for X and Y. All right, so our other point, we got two other points. You get to pick which one, it doesn't matter. I'll use the negative 7, 18 that was given to us. So X is negative 7, Y is 18. And I'm going to plug those in for X and Y in my equation. So I get 18 is equal to A times negative 7 plus 3 squared minus 6. And then solve for A. I'm going to pause here, give you a moment, see if you can solve for A. What are you guys getting for A? 3 over 2? Good. Okay. 3 over 2 is what you want. You got to follow, well, parentheses first, you get the negative 4. Negative 4 squared is 16. You cannot do 16 minus 6 because the 16 is attached to the A and the 6 is not. They're not like terms, right? So instead, you got to add 6 to both sides to get 24 is 16A. Divide by 16 and reduce to get 3 halves. Once you have that, then you can plug A into the original equation, and I highlighted that at the top. Its y is 3 over 2 times x plus 3 squared minus 6. And now we got our first equation. Yay, right? We're in business. Okay. Once you have vertex form, go to standard form. So I'm going to start with vertex form 3 halves times x plus 3 squared. That's x plus 3 times x plus 3 minus 6. And I'm going to multiply all that out. Again, I'm going to pause here. Go ahead and try multiplying all that out correctly. We just need practice here. right, what y-intercept are we getting? Should be a fraction. 15 over 2. If you get 15 over 2 for your y-intercept, you're probably doing it right. I'll show you in a second here. Okay, here's my work. I highlighted the standard form that you want to get. 3 over 2x squared plus 9x plus 15 over 2. If you plug in 0 for x into that, you'll get y as 15 over 2, and that's how we're getting our y-intercept. So yes, you can have fractions for a, b, and c. Okay, it still works. Any question on that part? What's the next step? Factor. We got to factor this thing? Can we factor this thing? The answer is yes. But this might be the first time you're factoring things with fractions. It's not too bad. It's just the first step, and let me show you that. Okay. So, what do you think, before I write anything, what do you think the first step is going to be for factoring? You're wanting to get rid of that fraction in there, right? Yeah. Now, if you could do that, if you multiply everything by 2, you're going to also have to multiply the y by 2. And typically, we just leave, so you're working with both sides of the equation when you do that. And you could do that. Instead, what I'm going to do, I'm just going to work with the right side. I'm going to leave y, but I still want to remove that fraction. Instead of multiplying by 2, I'm going to factor out the fraction, 3 over 2. So it's just going to be up in front, kind of like the vertex form. The 3 over 2 is just out in front. And so I'm going to write, before I do that, to get ready for that, I'm going to kind of get everything to have a common denominator. So I'm going to write 3 over 2x squared. Instead of 9, I'm going to put 18 over 2 plus 15 over 2. So now each fraction is something over 2, which makes this next step a little easier for you. So I'm going to factor out a 3 over 2, and the question is, well, what will be left? Okay, you're used to factoring out integers, but it's the same kind of thing. You're thinking, well, 3 over 2 times what equals that number? If you can come up with that what, then you can get it. So what do you think is going to be first? X squared, okay. And then plus 6x, good, plus 5, good. And once you're there, now it's back to, okay, I could factor that, right? We got integer values, not too bad. Thinking what two numbers multiply, and so on. Go ahead and finish that and get to your x-intercepts. And you should get something like this. 3/2 times x plus 5 times x plus 1. And you get two x-intercepts, -5, 0, -1, 0. And now we got all three equations. We have a lot of information. We're pretty much done with this problem. So in this graph, somewhere over here, this would be maybe our x-axis. And what we just found, okay, I can get that out of the way. What we just found is one of the x-intercepts is here at -5, 0, and another one here at -1, 0. So I'm going to put 5 points in my table. -7, 18, -5, 0, -3, -6, -1, 0, and 118. You could also put in the y-intercept if you wanted, but it's asking for 5 points, and that worked. All right, so lots of stuff there. Any questions from you before we leave this? This is what you're going to be doing on number 14 on your own, okay? It'll be very similar to this. All right. On to the on to the next page. So this one also starts with graphs. Different clues. If you look at 15, what do they give us on 15? No vertex. What do they give us? They give us the x-intercepts, right? And we can recognize the x-intercepts. Y is equal to 0 on your x-intercept. And then they get an additional point. That one's going to be for homework, okay? And so I'm going to do the next one with you. And I'm going to do it in a way that will help you with 15, okay? So on 16, I didn't put it, but there should be a V here. What do I have on 16? A vertex and a x-intercept. So I could think of this as a vertex and an additional point and do it like we did the last problem, but that wouldn't help you with number 15, right? Number 15 gives you x-intercepts. So I need both x-intercepts. Could I come up with my other x-intercept? Sure. What's the other one right here? 2 what? 0. Because those points, we have this axis of symmetry or line of symmetry going right down the middle. And the middle is at 4. And I go 2 to the right to get to 6. So I go 2 to the left to get to 2, and they're the same height. So those are my two x-intercepts. So I'm going to think of this problem as two x-intercepts and some additional point. Yes, that's a vertex, but I'm going to pretend it's just an additional point and work from the x-intercepts, because that will help you with the one that you need to do. Also want to point out down here some instructions on what to do when you have x-intercepts, okay, so that you can refer to if you get stuck, right? All right, so let's start with filling in what we can on this graph. Starting with the axis of symmetry. Alexis, what would the axis of symmetry be? Equals 4, good. And so then, Kelsey, what would the well, we know the vertex. I'm not going to ask you that. And we know the domain is all real numbers. So Kelsey, I'm going to ask you the range. Y is greater than or equal to -3. Good job. Where is this increasing, Natalie? Yes. You did right. Good job. And where's it decreasing, Natalie? That sounds more confident. Good job. All right. So we have those, right? And that's what we're going to work with. So I'm going to work from my x-intercepts, not my vertex. We just saw how to work from the vertex. But if you have x-intercepts, we're going to put those in here, and we're going to work from those. So you can get factored form from your x-intercept. We got 2, 0, and 6, 0. On yesterday's homework, one of the reflection questions was, what's the relationship between x-intercepts and factors? Remember that? So if 2 is an x-intercept, what factor belongs to that? Anybody know? Good. X minus 2. X minus 2 will give you 2. If you look back to the problem we just did, negative 5 is an x-intercept. What factor gave us that? X plus 5. Negative 1 is an x-intercept. The factor that gave us is x plus 1. And so there's this opposite relationship there. So, and you can work that way, and that's the way we need to work on this one. We're just working backwards. So I have 2 as an x-intercept. I'm going to write this. Y equals, we're not sure what A is, but x minus 2 is the factor that gives us the 2. And x minus 6 is the factor that gives us 6. Does that make a little sense to you, where that's coming from? Okay. So that's your first step, setting that up. The next step is to find A. And that's why we need a third point. Okay? And so we already used our x-intercepts, but that third point is the 4, negative 3. In this case, it happened to be the vertex. It does not have to be a vertex. And on the previous problem, you won't have the vertex, but you could still do it this way. So I'm going to use that 4, negative 3. What do you think I'm going to do with that? Plug it in for x and y, and that will help me find A. So negative 3 equals A times 4 minus 2 times 4 minus 6. Why don't you finish that? Solve for A and get the factored form. What are we getting for A? 3/4? That's correct. And so there's our factored form. All right, once you have that, we can easily write our vertex form. And I'm going to ask, how about Sean? Give me my vertex form. Y equals. And we know our vertex is 4, negative 3. So not 4, but x. Good. Perfect. So we got our vertex form. All right, and we need standard form. So we can get standard form from either vertex form or factored form, doesn't matter. We just multiply it out and you end up with it. So which one looks easier to work with to you? Factored form, multiply that out, or vertex form? Factored? Okay. Let's multiply out the factored form to get standard form. So y equals 3/4 x minus 2 times x minus 6. Go ahead and multiply all that out. Get standard form and find the y-intercept. What are you getting for the y-intercepts? What'd you say? Did you get the y-intercept yet? Not yet. You should be getting 9. Okay. So standard form is 3/4 x squared. I forgot my x squared. Be a squared there. Minus 6x plus 9. And then your y-intercept is, if you plug in 0 for x, you're going to get y equals 9. All right, so we have an extra point that we can put on this picture. We got a y-intercept over here at 0, 9. And if we know that point is on the left side, there's a matching point on the right side that we can find. Logan, what's that point going to be? Okay, I'll catch you up here. So I just put the 0, 9, our y-intercept, right here. So what's going to be the point straight across from it? Well, the middle's at 4. So 4, 9 would be like right here. It's a little bit to the right of that. There we go. You see why? Okay. So 8, 9, because 4 is the middle. We got to go 4 to the left to get to 0. We got to go 4 to the right to get to 8. And now we have our 5 points. And we did it. Give yourself a hand, yeah. Okay, so 15 will be like that. Okay. Any questions before we leave 16? What's that? Okay. All right, then one more problem on the next page. We're going to do 18 together. And 17 will be yours for homework. All right, so on 18, Robert, what's the vertex going to be? What's that? Not sure. So your vertex is going to be HK. And where that's helpful is if you look at our formula here, you can see where H is positioned and where K is positioned in that form. So now you're going to kind of draw it out of this equation. And it's going to be negative 5 because it's always the opposite of what's here. So negative 5, 1. Okay, good. Mac, what's the axis of symmetry going to be? Close. Negative 5 is a number, not a line. There we go. X equals negative 5. We don't have a graph to work from, so we're going to save all the graphing questions for later. So what's a good next step? Find standard form. So we're going to go this direction by multiplying all that out. So negative 1/9 times x plus 5 times another x plus 5 plus 1. Go ahead, multiply that out, find the y-intercept. So 0, negative 16 over 9. Okay. How are we doing with that? Okay. Got a question? No? Okay. So then we got to factor that. And we the last one we factored had a little fraction, and we got to do the same kind of thing. What do you think our first step is? Factor out that 1/9. Think you can do it? Okay, try it. Try to get started. In a moment, I'll show you the first step, but see if you can do the first step. So your first step looks like that. After that, keep going, get your x-intercepts. Getting -8 and -2 for our x-intercepts. And then our factored form is y equals -1/9 times x plus 8 times x plus 2. And now we're ready to graph. Tyler, when I graph this, is this graph going to open up or open down? Open down, why? Not sure? It has to do with A. What is A? If A is negative, it opens down. Okay? And so, Luis, is the vertex going to be a maximum or minimum? Maximum. Why? Because it's opening down, so that vertex will be a highest point. Good. So we're ready to graph this. The highest point is at a height of 1, so I'm going to move it over to the right and make my x and y axis look something like that. So my vertex is at -5, 1. I have an x-intercept at -2, 0. And at -8, 0. I have a y-intercept at 0, -16/9. Where's -16/9? Or how many times does 9 go into 16? Once with the remainder, right? It's almost -2, but not quite. So I'm going to drop down. I'm going to put something between -1 and -2, but I'm going to also give it its exact value. So I'm going to put 0, -16/9. And then there's a matching point on the other side that we need to know its coordinate. -10, -16/9. And now we could sketch our parabola. Domain's all real numbers. Domain's always talking about your x values. For our range, Matthias, what's the range going to be? What'd you say? Less than or equal to? -5 is an x value. 1, good. And where's this thing increasing, Maddie? Greater than what? -5? So what I didn't put in my graph, let me do this, is the middle. Right here's our axis of symmetry. Cuts it right down the middle at x equals -5. And so if you say x greater than -5, you're talking about the right side, right? And as I trace it, is it dropping or it's dropping? So it's decreasing. So it's going to increase not on the right side, but on the left side. As I see that, so it's going to be less than, and then decreasing x greater than -5. And then we can fill in our 5 points, and we got it. All right. See you Thursday. I'm here at lunch and after school if you need extra help. Plan on a quiz on Thursday.